Hi POE students, I'm going to help do some of the stress strain calculations from this activity as examples for us. I've started with number 4 just as one to pick, and so let's begin. Practicing good problem solving skills for word problems. We're going to draw a picture, identify our knowns and our unknowns, what equations we might use, and then show our work. I will note, just make sure you have reviewed the formulas that we're using in this activity. If you need, you can go back and watch the other video that I posted that discusses the formulas. I'd also note that this is a great time when you're practicing and doing problems to use your POE formula sheet just so you can continue to get familiar with the layout of this sheet. Since this is the one that you get to use for the end of course exam, you want to be familiar with this and just remembering, the notation and how things are noted. So, okay, so I'd have that handy for yourself. Okay, looking at number 4, we'll read it. It says a 4-inch wide by 1 1/8 inch thick rectangular steel bar supports a load of P in tension. Okay, so let's just give ourselves a quick picture. We have a rectangular bar, so I'm going to draw a rectangle. Kind of extrude that down. Don't know how long it is, but we've got this rectangle, and it was 4 inches wide by 1.125 inches thick. Okay, and so those are our knowns as well. Determine the stress. Okay, so unknowns. Generally, those are things that you're being asked to solve for. So we don't know stress. That's something we want to find. And I'll just even note for this problem that it was part A. Part B, they actually ask us for the load. You can call that P if you want, or a force, but basically we have a force. In this problem, they're calling it P in general. Okay, other knowns, other things we know. For part A, we're told that P is 32,000 pounds. Okay, so let's do A. I know that I have a force of 32,000 pounds. I know I want stress. So I need to find a formula that I can use that would relate the information that I know, a force, dimensions of this cross-section, which should lead to the area, the cross-sectional area, okay, to help me find stress. So you may remember, so let's just write equation, that stress is equal to the force divided by the cross-sectional area. I don't directly have the area, but I've got the information needed to find it, right? I've got the length and the width. So if we multiply those two, we've got the area. So really, while it wasn't directly given, indirectly I've got what I need. So 4 times 1 1/8 is going to be 4.5. And that'll be square inches. Okay. So for part A, there you go. Stress is force over area. The force is 32,000 pounds. The area is 4.5 square inches. So I need to divide 32,000 by 4.5. And in the end, this question says to give precision to the nearest hundred. When I divide this, I get 7,111.1. And so rounding that to the nearest hundred, it's just going to be 7,100. And our units here is pounds per square inch, so you may see that written as PSI, pounds per square inch. Okay, so there's part A. Part B asked us to find P, which is a force, and in part B, they said the load P, so that's what we're going to determine, the load that can be supported by the bar if the axial stress must not exceed 25,000 pounds. So this time they're telling us that the axial stress must not go over 25,000, so it needs to be less than or equal to 25,000 pounds per square inch. Okay. So this time they basically switched up the two things. You know, here they asked for stress, but they gave us a force. This time they asked for the force, but gave us this. So part B, I'm still going to have stress is equal to force over area as our relationship, right? And this time we're told that the stress should not exceed 25,000 psi. So we've got the 25,000 as our stress. They're asking for this load, this amount of force. They've called it P, so I'm going to do P. Over again, still the same cross-sectional area of 4.5. Now, normally I put an equal sign here, and this is the expression that represents stress that we're solving for. Okay, and we want this right here to not exceed 25,000, right? So to not exceed means they could be equal, but if they're not going to be equal, we would like this to be what? Bigger or smaller? Think if we use the phrase that we don't want our stress to exceed 25,000. That should mean that we want it to be less than or equal. So I'm reading from this side. This needs to be less than or equal to the 25,000. Sometimes students get reading the inequalities backwards a little mixed up, but remember the alligator wants to eat the bigger thing. So when I read this from right to left, I would say less than. If I read left to right, this symbol would say greater than or equal to. Anyway, I'm pretty sure I got the inequality right. Okay, so this right here we're solving for, setting up an expression that represents stress. Okay, with our variable in it that we're solving for, we want this to not exceed 25,000. So algebraically, I'm just going to multiply both sides of the equation by 4.5. By doing that, I get the 4.5 to cancel out, and I find that P, again reading from right to left, is less than or equal to, this is 112,500, and that was inch squared, and this was PSI, pounds per inch squared. So those inch squareds are going to cancel out. We're going to be left with just pounds. They asked for a precision to the nearest 10,000. And so really I kind of want to just go down. I want this to be under that. So let's just walk it right back down. And I'm going to flip this around. I know we like to read with the variable on the left, kind of reading left to right. So flip your inequality if I flip the order. So we're going to say that P is less than or equal to 110,000 pounds. Okay, there's part B. So we got A was 7,100 psi and B was that.